Lesson 11.3 is about the areas of trapezoids. So remember that a trapezoid is a quadrilateral with two sides that are parallel to each other, just one pair of parallel sides. And it has basically two bases. So let's refer to these as base 1, which we'll put B sub 1, and base 2, B sub 2. Those are the two sides that are parallel. Now, the height of the trapezoid is, like all heights of these figures, is measured from base to base as a segment that hits perpendicular to both bases. So that would be the height of the trapezoid. So the area of a trapezoid can be determined by multiplying together the height and the average base length. And the average of the base lengths, we just take the sum of the two bases and divide it by 2. And another word for that is the median. And you might remember that from previous lessons, that the median is parallel to the sides, to the two bases, and is actually the average of the two base lengths. So if you add them up and divide by 2, that's the length of the median. And it happens to bisect each of the two other sides. So another way of saying the area of the trapezoid is the height times the median. Okay, height times average base length, or height times median. And remember that the height is always measured as a perpendicular segment between the two bases. It's an altitude. So in this first example, we have a trapezoid, and the two bases have length 5 and 13. And we know that those are the parallel sides because they're cut by the transversal that's and it's perpendicular to both of those. So anyway, the area of this can be measured as the height times the median, or the height times the average base. So the height of this, I have to look for a segment perpendicular to the bases, and it happens to be this left side of the trapezoid, that other leg. So that's let's go height, and then we'll find the median, which is the average base. So this is going to be 6 times. Now the average base length is the sum of the two bases divided by 2, because that would give us an average. So this is going to be equal to 6 times 18 divided by 2, or 6 times 9, which is 54. And this number here, remember, is the average base length, which we also call the median. Okay, in this next example, I have a trapezoid, and I know that this is an isosceles trapezoid because I have the two, legs here are the same length and the two base angles are the same. So this is a completely symmetrical trapezoid, but I'm missing this top base up here. So this is where I get to work using my right triangle experience. I see I've got 60-degree angles in the corners. I know I have to find the height of this trapezoid, so connecting from base to base with a perpendicular. So what if you add in two altitudes like so, we make some 30, 60, 90 right triangles. So I use the opportunity when I have a 30 or a 60 or a 45-degree angle to do that. So now I'm looking at the little triangle, and let's just look at the one on the left. The hypotenuse is 6, and short leg is down at the bottom, opposite the 30-degree angle. Then short leg will be 3, and long leg, which is the height, will be 3 times the square root of 3. Okay, and now I have the exact same thing on the other side here. So this piece, this piece right here is also 3. Okay, now, if I did know originally that this whole distance across the bottom was 10, And this is not drawn to scale, clearly, but I just took off 3 and 3. I just took off 6. It makes this piece in the middle 4, which is equal to the base length of the top base there. So now I think I've got all the information I need because I have the two bases, the 10 and the 4, and I have the height of 3 root 3. So the area of this figure is equal to, let's go with height, times average base length. So add these up, 10 plus 4, and divided by 2. So this is 3 root 3 times 14 divided by 2, which is 7. So we get an area of 21 root 3, and that's going to be in some kind of square units. Okay, on this one I have a trapezoid, and the two bases are here and here. And take the opportunity to carve these things up to find, I need to find this base length here, and I need to find the height here. So I notice I have a 45-degree angle in the top right corner. So I'm going to subdivide this into some kind of a rectangle and a 45, 45, 90. So because I know if this is a 90, that this is the other 45 down in the bottom. So now to get from hypotenuse back to leg of a 45, 45, 90, I have to divide by root 2. So 3 root 2 divided by root 2 leaves a 3 here on this side and a 3 on this side, which is going to be the height of that. And then I know that on the top here I've got a 4 right here, so the entire base across the top there is 7. So in this figure, the area is height times the median. So the height is 3, and the median, which is the average base length, is 7 on the top base and 4 on the bottom base. The average of those two is 4. So the height of 3 times the median of 11 halves. So we get 33 halves, which is 16 and a half. So, and that would be in some kind of square units. And that's it for the area of trapezoids.